All right, now that we have reviewed what we already know about trigonometry from geometry, we're moving on to talk about angles and angle measures, but we're going to move beyond acute angles to angles of any size. So we're going to talk about drawing and finding angles in standard position, and we're going to talk about converting between degree and something called radians. We're going to learn a new way to measure angles. There's a lot of vocabulary in this section again, so make sure that at the end you can identify and define each of these terms. All right, we're going to start by talking about angles in standard position. An angle in standard position always has its vertex here at the origin and one ray, which we call the initial side, on the x-axis. So this ray is fixed, it doesn't move. And then we measure from the positive x-axis and we get to what we call the terminal side, so where my angle ends. So if you notice this angle here, it goes and it hits 90 degrees, it goes past 180 degrees, so this is an angle that is bigger even than an obtuse angle. So we have an initial side and a terminal side. The terminal side is where it terminates or ends. So to measure an angle, we find the amount of rotation from the initial side, which always starts on the positive x-axis, to the terminal side. If my angle measure is positive, I'm going counterclockwise. So if I go this way, like you can see with the 120-degree angle here, if I go counterclockwise, that is a positive angle measure. In this chapter, we will also be dealing with negative rotation, which is when I start at the positive x-axis and I move clockwise. If I measure in this direction, my angle will always be negative. All right, so we're going to draw an angle in standard position that measures 210 degrees. So a good way to think about this is how far past 180 degrees do I have to go? Well, I know that 210 is 180 degrees, which is a half circle, a straight angle, plus 30 degrees. So we draw, our initial side has to be here on the positive x-axis. Then I go to 180 degrees. 180 degrees would stop here, and then I have to go 30 degrees more to get my 210 degree angle. All right, if I want to go negative 45 degrees, since I'm going negative, I have to go in the clockwise direction from the positive x-axis. So I start here, here's my initial side on the positive x-axis, and I go 45 degrees in the negative direction. It'll help to think of each quadrant as being 90 degrees, right? Remember that each quadrant is a right angle, 90 degrees, and so if I'm going 45 degrees in the negative direction, I have to go halfway through the fourth quadrant. All right, so here are two for you guys to try. Here's the first one. The answer here was D. That was pretty easy to see. And negative 60 degrees is C. Notice, again, I have to measure from the positive x-axis, so D does not work because it's measuring from the wrong starting place. My starting side, my initial side, is always on the positive x-axis. All right, sorry for this dark picture, but this is just to show you that I can actually measure angles or amounts of rotation that are more than 360 degrees. So if I were to start here with this angle, if I go all the way around once back to my initial side, I've done 360 degrees. And if I go 120 degrees more, so 90 degrees plus 30 degrees more, I end up with a 480 degree angle, or 480 degrees of rotation in the positive direction. So here we have an application of that. In a springboard diving competition, a diver made a 900 degree rotation before slicing into the water. So we're going to draw an angle in standard position that measures 900 degrees. So we have to figure out how many times do we have to go all the way around. So I'm going to have to go all the way around twice, and then an extra 180 degrees. So it usually helps to break these angles up into sections of 360 or 180 to figure out how many times you need to draw your terminal, or I'm sorry, your angle, how many rotations you need to draw for your angle. So we draw our terminal side, our initial side is here on the positive x-axis. Then I go around once to come back to here, twice. So far I've gotten to 360 twice, and then to get to 900, I go to 180 degrees, and my terminal side of my angle ends over here. Okay, so notice I have to show all of those rotations, otherwise it'll just look like a 180-degree angle. All right, so you guys try this one, a 600-degree angle. All right, in this case, the question was how far past the positive x-axis does it have to go? Well, 600 degrees is 360 degrees plus 240 degrees. So I started at my positive x-axis. I went all the way around once, and then I have to go an extra 240, which is 180 plus 60 to get over here to my terminal side. All right, notice that what I was saying before, if we look at this angle, if I don't draw all of these rotations in the middle, it would be easy for a 600-degree angle to look like a 240-degree angle, right? They end at the same place. Angles that happens to are called coterminal angles. Coterminal angles have the same terminal side. So for example, here I have a 60-degree angle. I start at the positive x-axis and go up 60 degrees. If I go from the positive x-axis in the negative direction until I end at the same spot, I have a negative 300-degree angle. So 60 degrees and negative 300 degrees are coterminal. Coterminal angles are always different by multiples of 360 because I have to do a full rotation usually to get back to the terminal side. So here we're going to find an angle with a positive measure and an angle with a negative measure that are coterminal with 210-degree angle. So to get my positive angle, I'll just add 360 degrees to that. I'll add an extra circle. To go in my negative direction, I subtract 360 degrees. So that would give me 570 degrees and 150 degrees. Let's draw that and see what it would look like. All right, so here in black, I have my original 210-degree angle drawn. So if I want a coterminal angle with that's in the positive direction, I start at the same place, right? But I have to go all the way around once and then come back around and end at the same place. So it's 360 degrees extra, or added to 210 degrees. It's an extra rotation, so that gives me 570 degrees. If I want to go in the negative direction, I'll try to draw that in red. I know this is getting a little messy, but I start at the negative x-axis, or I'm sorry, the positive x-axis, but I measure in the negative direction, and that gives me negative 150 degrees, right? So negative 150 degrees ends up at the same spot as positive 210 degrees. They have the same terminal side. All right, we're going to do the same thing here. So I have negative 120 degrees. They skipped their negative sign here. So to get a positive angle, I add one rotation, 360 degrees, to get 240 degrees. To get a negative coterminal angle, I subtract 360 degrees from negative 120 degrees, and I get negative 480 degrees. So now I want you guys to try this one. Find the smallest angle with a positive measure and a negative measure that are coterminal with 330 degrees. All right, your answer here should be A. And here was the process for getting those. I took my original angle and added 360, so I added one rotation. That gives me a coterminal angle of 690 degrees. And when I subtract one rotation, I get negative 30 degrees. All right, now we're going to get into a new way to measure angles. We are used to measuring angles in degrees, and in class we'll probably see a video that'll talk a little bit more about this, but another way that we can measure angles is called radians. And at first this is going to seem really weird because we're so used to thinking in degrees, but basically 1 radian means, if I take the length, if we look at this circle over here, the length of my radius, right? An arc, so this arc on my circle right here, if this arc is the same length as 1 radius, that angle measure is 1 radian. Radian basically means how many radii am I cutting off of the edge of my circle? How many radii fit into the arc of the circle that is subtended or intersected by the central angle? So how do these work together? 1 radian, again, cuts off an arc of 1 radius in length. We know that the circumference of a circle is 2 pi times the radius, right? So if I go all the way around my circle, 360 degrees, I have 2 pi radiuses or radii, right? I have 2 pi radii all the way around my circle. So that means this is our conversion factor. And again, we'll talk a little bit more about where this comes from in class. Right now, you need to be able to just convert. 2 pi radians is the same as 360 degrees. So if I start here and go all the way around, I've done 2 pi radians, or 360 degrees. We can divide both of those by 2, and our conversion factor is that pi radians is the same as 180 degrees. Okay, so again, here's the conversion factor to see it a little bit better, and we'll talk a little more in class about what this means. But if I want to go from degrees to radians, I multiply by pi over 180. Pi radians over 180 degrees. If I want to go from radians to degrees, I multiply by 180 degrees over pi radians. This is just like unit conversion or unit analysis that we've done before and that you've done in science classes. So I want to take 30 degrees and I'm going to rewrite it in radians. Okay, so I'm going to multiply 30 degrees by pi radians over 180 degrees. So this is just like unit analysis. I'm basically getting my degrees to cancel out or divide off. So I end up with 30 pi over 180 radians, which reduces to pi over 6 because 30 over 180 is 1/6. So 30 degrees equals pi over 6 radians. I can go the other way as well. I can take something that's in radians. I can tell this is in radians first because it has the pi, but it doesn't always have the pi. But notice it does not have a degree symbol. So here I need radians to cancel off. And if it makes more sense to you, go ahead and write the radians out. So negative 5 pi over 3 radians, I need to multiply by 180 degrees over pi radians. This is a conversion factor that's equal to 1. So my radians cancel out or divide out. My pi's divide off to 1. And I'm left with negative 5/3 times 180 degrees, which is negative 900 over 3, or negative 300 degrees. So right now, you just need to be able to go back and forth. So try these next two. All right, 45 degrees in radians is pi over 4. And there's the work to do the conversion. 45 over 180 is 1/4, so I have pi over 4. All right, now we're going to go the other way. I'm going to take something that's in radians, pi over 6, and rewrite it in degrees. All right, the degrees here is 30 degrees, and there is the work for that conversion. Okay, this is a summary of degrees and radians for the main angles that we have to know. These are special angles. So notice I have 30 degrees and 60 degrees and 90, right? So 30, 60, 90 triangle, and 45, 45, 90. So 30, 45, and 60 are my main angles, and I need to know the multiples of those angles all the way around the circle. I need to know those in degrees, so I need to recognize 120, 135, 150, and so on, all of those degrees. And I need to know that 30 degrees in radians is pi over 6. I need to know that 45 degrees in radians is pi over 4, and so on. We'll talk a little bit in class how I can get every other angle on here if I know the first quadrant really well. But this is a circle. This is called the unit circle. You will need to have it memorized. It is going to be one of your best friends in this chapter. We're going to practice it and practice it. You have to know this, okay? So start out by learning the first quadrant really well, and we'll talk about how to go from there. All right, one last thing that this section talks about, find just a little place to write this on your note guide, is arc length. If I have a circle that has a radius r and a central angle, that's an angle whose vertex is at the center, theta, measured in radians, that's the key. The arc length, which they call S, is the product of the radius, the length of the radius times the angle. So this is the arc length formula. Again, that angle has to be in radians. And so, real quick, we'll just look through this example. So if you read that, we know our radius is 11. I'm doing 4/5 of a rotation. So notice here I'm working in radians instead of 360 degrees. I'm using 2 pi. 4/5 of 2 pi is 8 pi over 5. So that's my central angle in radians. And then I'm going to use my formula. The arc length is the radius, which is 11, times the angle, which is 8 pi over 5. And then I go ahead and multiply, and I put on my correct units, which in this case is inches.